So in last point, we have seen that hybridization of carbanions, different geometries of carbanion and generation of carbanions. Now in this lecture, we will go for stability of carbanions. So which factors are responsible for the stability of carbanions? So carbanions, we have seen that carbanions they can have sp3 hybridization, sp2 hybridization, as well as sp hybridization as well. Also, sp3 hybridized carbanion is having trigonal pyramidal geometry. Sp hybridized carbanion is having linear geometry, and sp2 hybridized carbanion is having bent type geometry. Okay, so these points we have been covered. So today, stability of carbanions. So entire factors which decreases the negative charge density on carbanion increases its stability. That means stability of carbanions is inversely proportional to the negative charge. Okay, inversely proportional. That means the factors which absorbs or extracts the negative charge of carbanion, so absorption of or withdrawal of negative charge of carbanion makes them more stable. Okay, so the interfactor which decreases the negative charge. So in short, electron withdrawing groups, if they are present on next to the carbanion center, so that carbanion is, we can say that one is the more stable. So we will see one by one which factors they are responsible for the stability of carbanions. So first factor, we can say that electronegativity of carbanionic carbon. Okay, so the stability factor is depend upon the hybridization of that particular carbon atom. Okay, so here we can see hybridization of different carbon atoms. So as we have discussed for the hybridization leads to different hybridization leads for the different geometries of the carbanion. Now again, the same point of hybridization explains how different hybridizations responsible for the stability of the carbanions. Okay, so the stability directly proportional to electronegativity of carbanionic carbon, which is directly proportional to the percentage of S character of the carbon anionic carbon. Okay, so that means we have to go for again the hybridization of that particular carbon atom which holds the negative charge. Okay, so the negative charge sp3 hybridized carbon atom also holds here negative charge. Here sp2 hybridized carbon atom also holds the negative charge, and here sp hybridized carbon atom holds the negative charge. Okay, so all these hybridization, they explains or they defines the stability of this carbanion. Okay, so here we can say the percentage of s character is increasing. Okay, so the percentage of s character is increasing, the stability is increasing. Okay, so here you can say in sp hybridization, percentage of s character is 50% and percentage of p character is 50%, and stability also increasing as percentage of s character increasing. Okay, so it's very simple that increasing s character in the hybridization of an atom is effectively increasing its electronegativity. Okay, so this is the, so the percentage of hybridization, percentage of s character is directly proportional to the stability of that carbanion. So here we can see again sp3 hybridized carbanion, sp2 hybridized carbanion, and sp hybridized carbanion. So here you can see I have given here the order of stability of all these three hybridization and all these three carbanions. So here you can see sp hybridized carbanion is most stable, then sp2 hybridized carbanion is more stable, and sp3 hybridized carbanion is least stable out of these three. So why that one is like that? So s orbitals are closer to the nucleus. So I have told that if more s character is there, that carbanion is more stable. Okay, so here we can say here sp hybridized carbanion, s percentage of s character is 50% and percentage of p character is 50%. Okay, so the both hybridization, so both percentage of both s and p is 50-50%. Okay, so that's why as percentage of s character is increasing in s orbital. Okay, here in sp hybridized the s orbital percentage is 50% and p orbital percentage is 50%. So that's why that one is more stable. So why the this thing are like that? So here is the answer. The s orbitals are closer to the nucleus than the p orbitals. Okay, so I'm telling now why the s character, if s character percentage of s character is increased, why the stability of carbanion is increasing. So s orbitals are closer to the nucleus than the p orbitals. So the electrons that are in s orbitals are closer to the nucleus than electrons in the p orbitals. Okay, and therefore lower in energy. Okay, so electrons which are closer to the nucleus possess positive, okay, positive charge also. Okay, so there is attraction in between orbit electrons which is present in s orbital, electrons and protons. There is a attraction in between these two opposite charges, and that's why that one it leads to lower in energy. Okay, for this reason electrons that are in sp orbitals are lower energy, okay, than sp2 orbital, and which is again more lower in energy than sp3 orbitals. Okay, so very simple things are here. If you remember that nucleus and around the nucleus, our lobes are revolving. The electrons are revolving in that outside lobes. S orbital is closer to the nucleus. After s orbital, p orbitals, three p orbitals, they are residing, and as we know, electrons which is present in s orbital, they are closer to the nucleus, and in that way these electrons is in closer contact with the protons which is present in the nucleus. So there is a interaction in between these electrons and protons. So that's why due to this interaction the energy, this sp hybridized orbital, sp hybridized carbanion is in lower in energy due to this opposite charge attraction, and that's why as s is in 50%, s orbital is in 50% and p orbital is in 50% hybridization. So more electrons present, 50% electrons present in s orbital, 50% electrons present in p orbital. So 50% electron they are in close in contact with the nucleus in sp hybridized orbital. That's why that one is in lower in energy, and as energy is lower, this hybridization carbanion which is residing on the sp hybridized carbon atom, this carbanion is more stable than the sp2 hybridized or sp3 hybridized. In sp2 hybridized in sp2 hybridization, the s character is 33%, and in sp3 hybridization s character is 25%. That means electron density